All right, let's get right into this explainer. Today, we're looking at how the Indian Space Research Organization, ISRO, basically rode the massive momentum of their historic Chandrayaan-3 moon landing straight toward the center of our solar system. I mean, right after touching down on the lunar surface, they immediately set their sights on a huge, fiery new target with their first ever dedicated solar mission, Aditya-L1. It's an amazing story of incredible engineering, strategic foresight, and really just the ultimate quest to understand the star that literally powers our entire world. But before we get into the actual nuts and bolts of the spacecraft, consider this mind-bending mystery for a second. It's baffled physicists for decades. Imagine you're standing near a campfire. As you step away from the fire, you naturally expect to feel colder, right? Well, with the sun, the exact opposite happens. Why does the sun's outer atmosphere completely defy the laws of physics by getting exponentially hotter as you move away from its surface? Just keep that question in the back of your mind, because answering it is one of the main reasons this mission even exists. So, we've got a lot of ground to cover today. Here's a quick roadmap. We'll start with India's next great leap, look at the Lagrange Point advantage, dive into solving massive solar mysteries, check out overcoming thermal challenges, discuss securing India's data sovereignty, and then wrap up with some essential memory triggers. Let's get to it. Starting off with Section 1, India's next great leap. To really understand the scale of this leap, we have to look at the core problem of studying the sun from down here on Earth. Now, historically, India has a really rich background in studying the sun. They've used ground-based telescopes for a long time, like the famous observatory in Kodaikanal. But there's a massive limitation there. Earth's atmosphere, which, brilliantly keeps us all alive, actively blocks a huge amount of solar radiation. That makes true deep space solar observation completely impossible from the ground. The atmosphere just obscures the full picture, which forces a necessary pivot into space if you really want to unlock the sun's deepest secrets. And what's super fascinating here is how the mission itself evolved. Back in 2008, Aditya was conceptualized as just a small satellite probe. But science is dynamic. By 2015, stakeholders like ISRO and the Indian Institute of Astrophysics, who actually built the primary payloads, decided to dream quite a bit bigger. The mission was upgraded from a modest probe into a massive multi-payload observatory-class mission. And that whole evolution culminated in a flawless launch in 2023, and by early 2024, the satellite successfully fired its thrusters to execute a highly complex halo orbit insertion. Which brings us to Section 2, the Lagrange Point advantage. The crucial thing to understand here is what this L1 destination actually is, and why parking there is Aditya-L1's greatest possible asset. So L1 stands for Lagrange Point 1. Think of it as this invisible gravitational sweet spot, an equilibrium point right between the Earth and the Sun. When a spacecraft parks in a halo orbit around L1, which is about 1.5 million kilometers away, it orbits the sun at the exact same rate as our planet. The massive advantage? Aditya-L1 gets an uninterrupted 24/7 view of the sun. There's absolutely no Earth blocking the view, zero eclipses. It is literally staring at the sun all day, every single day. Moving right into Section 3, solving massive solar mysteries. Remember that campfire analogy from earlier? This perfectly illustrates the coronal heating problem. The surface of the sun sits at a scorching but mathematically understandable 6,000 degrees Celsius. But as you move away from the surface and into the outer atmosphere, the solar corona, the temperature absolutely skyrockets to over 1 million degrees Celsius. It's a bizarre reality that completely defies standard physics. So, ISRO equipped Aditya-L1 with a primary payload called the VELC, or the Visible Emission Line Chronograph, which is explicitly designed to stare right into this phenomenon and finally solve this massive mystery. But look, this mission isn't just about scientific curiosity. It's highly, highly pragmatic. The sun is incredibly volatile. It regularly shoots out these massive bursts of energy known as coronal mass ejections, or CMEs. And these are not just pretty light shows in the sky. These solar storms have the power to completely fry the electronics on our communication satellites and even crash power grids right here on Earth. So Aditya-L1 acts as an invaluable early warning system. By detecting these space weather events days before they actually hit our planet, operators back home get the critical time they need to safely shut down and protect all that essential technology. On to Section 4, overcoming thermal challenges. As you can probably guess, staring directly into the sun for 5 straight years brings a colossal engineering hurdle. Space is an environment of absolute extremes. On the one hand, the satellite is operating in the freezing, absolute vacuum of deep space. On the other hand, the front of the craft is taking intense direct solar heat head-on, completely without the Earth's atmosphere to protect it. ISRO engineers had a truly daunting task with thermal management here. They had to design incredibly complex heat shields and highly efficient radiators. That was absolutely vital to ensure the ultra-sensitive optical lenses on instruments like the VLC didn't just melt, warp, or degrade under those punishing conditions over its 5-year lifespan. And conquering those immense engineering and thermal hurdles actually places India into an incredibly elite global club. Successfully placing a dedicated solar observatory at that specific gravitational sweet spot of L1 is very rare. Currently, it's just NASA, the European Space Agency, Japan's JAXA, and now ISRO that have pulled off this amazing feat. Section 5. Securing India's data sovereignty. When we look at the future outlook and the massive national advantage this brings, Aditya-L1 is absolutely packed with cutting-edge tech. It's carrying 7 distinct scientific payloads. 4 of them are constantly pointing directly at the sun to meticulously study its light across different spectrums. The other 3 are designed to measure the solar wind particles continuously flowing past the satellite. With all 7 of these payloads actively analyzing different layers of the sun simultaneously, India is gathering an unprecedented amount of its own scientific data. And honestly, the true value of all that data is independence. In the past, India had to rely on American or European satellites for crucial space weather forecasting. But with Aditya-L1, India gains complete data sovereignty. This means they no longer have to rely on foreign data to protect their own multi-billion-dollar communication satellite fleet orbiting Earth. They have their own dedicated eye on the sun, securing their infrastructure entirely on their own terms. Finally, Section 6, Essential Memory Triggers. Let's quickly lock everything we've discussed into a few essential takeaways. Whether you're studying for an exam or just want to remember this stuff for later, lock these buzzwords in. The location is Lagrange Point 1, giving that 24/7 view. The orbit type is a halo orbit. The core mysteries it's solving are the coronal heating problem and space weather. The major threat it's watching for is coronal mass ejections, or CMEs, and the key instrument making it all happen is the VLC payload. Keep those in mind, and you'll have a perfect recall of exactly why Aditya-L1 is such a monumental achievement. So, with the sun now successfully under ISRO's watchful observation, it begs an incredibly exciting question about where they're pointing their technology next. What deep, dark mysteries will ISRO's next mission, ExpoSat, reveal about the extreme, mind-bending physics of black holes? I'll leave you with that provocative thought to spark your curiosity, and we'll decode the mysteries of ExpoSat together in our very next explainer.